All right, these next few problems cover just a few on your practice tests. It's questions 15 through 17. We're talking about sequences in series. So, the first thing we want to see is what's the difference between a sequence and a series. And hopefully you recognize there's commas in all of these in the sequence, okay? But what do we have in the series? There's the plus signs. So, what is the big difference between a sequence and a series? A sequence is just a list in order, okay? But the series is the sum where you have to add them all up of the list in order. And they do have to follow some kind of pattern. That might be geometric, that might be arithmetic. And in this case, we can see that what are we doing to get from one term to the next? For each one, we are adding 4. And whenever you're adding or subtracting some number to get to each one, then that means we have a common difference of 4. Okay? So to find the 50th term in a sequence, like this one here, then we want to make sure we use our formula for the nth term, which was a sub n, equals a sub 1, our first term, plus the number of terms that we are looking for, or the number term that we are looking for, minus 1 times that common difference. Okay, so this is a good formula to make sure you have on your note card. And let's write down all the things that we know. Well, a sub n, that's the thing that we're trying to solve for, but a sub 1, sorry, my keyboard's popping up and getting a little glitchy. We have a sub 1 equals 1, and then n, the number term that I want to find is the 50th term, and my common difference is 4. So now we can start plugging everything in. So a sub n is going to equal a sub 1, 1, plus 50 minus 1, and that is times by 4, our common difference. Well, a sub n then is going to be 1 plus 49 times 4. And then 49 times 4, I can try to do that over here without the aid of a calculator. You can use one if you want. But that's going to be 196. And then I have to add the 1 to it. So that's going to give me 197. And that is my 50th term, a sub n. Okay? So what about finding the sum, or the working with a series? Well, what we end up with, since this is an arithmetic series, we look at the sum of that series is going to be our first term plus our last term that we want to add up. We divide that all by 2, and then we multiply it by the number of terms that we have. So I already have a sub 1. That was 1. And then I found the 50th term already, so that's pretty simple. That's 197. And then I have my n. I want to be adding together the first 50 terms. So the sum of the first 50 terms will be 1 plus 197 divided by 2, and that is multiplied by 50. So simplifying that, that gives me 198 over 2 times 50. I can divide 198 by 2. That gives me 99. And then 99 times 50, well, that's actually, I can do this as a real quick shortcut in my head. You can punch this in your calculator, that's fine. But I can think about that as 100 times 50, which is the same thing as 5,000. Okay? And then I want to subtract that, just one of those factors of 50. So 99 times 50 then must be 50 less than that, and that would be 4,950. And that is going to be the sum of my first 50 terms. Okay? What about the next thing, where we have this weird, crazy summation notation? Remember that this is that Greek letter sigma, and it tells us to sum, or add everything up. So we have our rule right here, 5 times m minus 2, and what we need to do is see how many times we want to apply this rule. Well, we're going to apply it from when 1 starts to equal 5, and when m equals, or from 1 all the way up to 5. So when m equals 1, 2, 3, 4, and 5, we are going to find those values. Just plugging in 1 for m. 5 times 1 minus 2, that's going to give me 3. 5 times 2 minus 2 is going to be 10 minus 2, that's 8. 5 times 3 minus 2 is going to be 15 minus 2, that's 13. And then 5 times 4, we get the idea. It's going to be 18. and that's going to be 23. Now, I want to take each one of these numbers over here, and I want to add them up. 3 plus 8 plus 13 plus 18 plus 23. I'm going to do it my shortcut way and add two numbers at a time. That's 41. That's 11. And then I could take 11 and 13, add those together, and then add that 41. Well, 11 plus 13 is 24. And 24 plus 41 is going to give me 65. And that is the sum of the first 5 terms in that sequence, 5m minus 2. Okay, so this should help you out differentiating between sequence and series, applying the a sub n rule and the s sub n rule, and also working with summation notation in pretty short order. All right, thanks guys.